Question 7, the right angle triangles, we've got a sine kind of A plus B situation, so we should be thinking addition formulae. Also, we're thinking we need to do Pythagoras to work out all of our triangle lengths. So I'll do this in red. I call this my red triangle. So if I'm trying to work out this missing length on the red one, I mean, you could draw these again if you want. I'm being a wee bit lazy, you know. So that's the Q triangle in red. Well, this length over here is going to be root 13 squared, take away 2 squared, all square root, isn't it? Just Pythagoras. So that's going to be 13, take away 4, pardon me, so that's going to be root 9, so that's going to be 3. I'll just double check I've done that right. So 3 squared plus 2 squared, so that's 9, plus 4 is equal to root 13 squared. Yeah, fantastic. So that's 3. Our other triangle, the green triangle. So this whole length here is 3 and this is 1. I'm just going to highlight that that's 2 for the red triangle so don't make a mistake. And this is R. This is where drawing your triangles out. If you were doing the exam, I'd suggest you do. I'm being a wee bit lazy here. And this length in here, that's going to be an add, isn't it? So that length is going to be 3 squared plus 1 squared square root. So it's going to be root 10. And again, just check we've done that right. 9 plus 1 is 10, which would equal root 10 squared. Fantastic. So let's do part A now. So 7a, if I've got sine of r, I'm doing the opposite over hypotenuse because it's so, so gratoa. And for r, the opposite is 1. I'll do this in green because it's the, but I'll do the whole thing in green just to keep the theme going. So sine of r, it's opposite over hypotenuse. So that opposite is 1, and the hypotenuse is root 10. So 1 over root 10, and that's you. For q, I'll do it in red. So that sine of q, again, is opposite over hypotenuse. So your opposite for that is 3, and your hypotenuse is root 13. So, 2 very nice marks, I think. And the next one, you're doing your expansion, first of all. So that's effectively a kind of A take away B. So when I write these out for an expansion, I tend to write the trig bit first. So if it's sine, I'm going to write sine and cos. And then I'm going to write cos and sine. And if it's a takeaway, it's still a takeaway. That's what this means. A plus gives me a plus, takeaway a takeaway. Whereas for cos, it's the opposite. If you've got a plus here, you're taking away. And then I'm writing A and B, which in my case is Q and R and Q and R. Fantastic. And I'll sub in what I know so far. So I know sine R is 1 over root 10. So I know that is 1 over root 10. And I know that sine Q is 3 over root 13. Okay, so let's go for cos R. Cos R adjacent over hypotenuse, so that's times 3 over root 10 without a code. And the cos Q, again, that's adjacent over hypotenuse, that's 2 over root 13. Fantastic. So we'll just put all that together. So I'm going to get 9 over root 130, take away 2 over root 130. So that's 7 over root 130. And let's have a think to see if we can reduce that. I don't think we can. Nope, that's as far as we can go. I was just trying to think if there's any nice numbers in here, 7 times table, stuff like that. But that is as far as we can do that. I'm just going to write that a little bit nicer. There, root 130. So your marking scheme for that one, you're getting a mark for your expansion, just for writing this. You're then getting a mark for your substitution, and a mark for your final answer. So just for doing that, you're getting a mark. Not too bad. So you see a right angle triangle, do some Pythagoras, and this, whenever you see anything like that, you're thinking it's going to be your addition formula. If it's sine 2x or cos 2x, you'll use your other formulas for sine 2x or cos 2x and do that. Okay, so that's question 7.